So last time we were looking at solving simultaneous equations, three methods. One, substitution, which involves rearranging the equation, one of the equation for one of the variables, so let it read y equals something or x equals something, and then substitute that into the other. Elimination, make one variable the same in both equations, then eliminate, or three, plot graphs. And all three methods are perfectly valid. The plotting the graphs method probably won't give you any accurate an answer, and you might not have access to software anyway to do it. So let's look at one example before we move on to what I want to really focus on today. Picked at random from the exercise on page 72, number 5. Let's try this. So, suggestion has been made to try elimination, so how are we going to do that? I might multiply equation number 1 by 2.4, which is the number for the x in number 2, so I get an amount, and then also multiply equation 2 by, what would I multiply that by? 1.5, right. So in other words, if I multiply equation 1 by 2.4, which is the value for x in number 2, and then I multiply equation 2 by 1.5, in other words, multiply by the other one effectively, then you should end up with x as being the same. So if we do that, what do we get? Calculators at the ready. So there we go, that's the equations. I multiply equation 1 by 2.4 and equation 2 by 1.5. I end up with the same x's. So now I can eliminate the x's. What would I do? I can do equation 4 take away equation 3, or equation 3 take away equation 4. Both would work, but one might be more convenient than the other. Which way would you go? Yeah, right, so I'd do equation 4 take away equation 3. Then I'd have 0.9 minus, there should be a y there, minus 5.8 is plus 5.28, so I get 6.18 equals 4 take away 3, 49.5, minus is plus 43.2, so I get 49.5, 89, 92.7. And then I can work out y. And once I've got y, substitute in to 1 or 2 to get x, and then check in the other one. Um, 0.9 minus 5.28 is plus 5.28. And there should be a y there, of course. I forgot to put in. So today I want to look at quadratic equations, solving quadratic equations. And we're going to do it by looking at an example of two simultaneous equations where we have a quadratic factor. So quadratic equations involve an x squared term. If x is our variable, then there'll be an x squared term in there. If our variable was y, then there'll be a y squared term in there, and so on. So x is a common symbol to use for the variable, so if you've got x squared, that means you've got a quadratic. That's all quadratic means. It's a term, the highest power in the expression is an x squared term. So let's look at an example of one. Here we've got two simultaneous equations, look. 3x squared minus 4y equals 2, equation number 1, and 8x plus 10y equals minus 10, equation number 2. I plotted this on autograph. Which curve corresponds to the equation number 1? Right, the curve. Okay, so the first thing to recognize about quadratics is that they involve not a straight line but a curve, and you would expect that's a classic shape for a quadratic expression. And equation number 2, is a linear equation involving just x and y, so I'm getting a straight line. So if I plot those two lines, we can see instantly that actually there's no value that satisfies both those equations, so we can't solve those simultaneous equations. So that highlights immediately the use of graph plotting software, because you're then not going to bother with the algebraic methods of elimination or substitution because there's no solution. Let's have a look at another example. I've just shifted the line a bit by changing it to 8x plus 10y equals 10. I've left equation number 1 the same, and now we see the lines do cross, and we actually notice that the line crosses in two places. So there are actually two values of x and y that satisfy those equations. Let's have a look at them. One's roughly, in this one, x is roughly 0.9, something like that, and y is around about 0.3, 0.4, and over this side, x is roughly minus 2.1, something like that, and y is roughly 2.7. So x equals around about minus 2.1, y is roughly 2.7. Here, x is round about 0.9 and y 0.3. Okay, roughly. So we know there are solutions, and that's roughly what we're going to get. So let's try now and solve them algebraically and confirm those solutions and get more accurate answers. Okay. Solve by substitution. There is my two equations, 1 and 2. Rearrange number 2, which is the easiest one to rearrange. Look for y. So rearrange number 2 so that it reads y equals something. Now just pause at this point, let you have a go at it. We get y equals 10 minus 8x over 10, hopefully. So now we substitute that into equation 1. Okay? So instead of y in equation number 1, write 4x, or whatever we got, which is 10 minus 8x over 10. And then try and fiddle around with it and solve it. Okay? And see what we get. Let's have a look. I've done this, so 3x squared minus 4y equals 2. You substitute in, we get this. 3x squared minus 4. Instead of y, we're writing 10 minus 8x over 10 equals 2. Then we multiply out this bracket. Well, actually, what I did first was, don't like a 10 underneath, so multiply both sides by this 10. That'll get rid of the 10 underneath. So I get 10 times 3x squared is 30x squared, minus, now I've got rid of the 10 that's underneath, so I'm just left with 4 times the bracket, 10 minus 8x, equals 20. So multiply through by 10 to get rid of the 10 underneath. Then expand out the bracket, so I get 30x squared minus 40, 4 tens are 40. Note, minus 4 times minus 8x gives plus 32x equals 20. So that's what I end up with. And I'll just pause while you get that far. So this is a quadratic equation. How do I know it's a quadratic equation? Because of the x squared. So how do we solve this thing? So what I want to do now is look at solving quadratic equations, look at some different methods for solving quadratic equations, and then we'll come back and use one of those methods to solve this and end up with our solutions. One of the things about quadratic equations, the first things to realize about quadratic equations is when we solve them, when solving a quadratic, we get two solutions. Except for a special case where we get one, but really it's two solutions, but the solutions are the same, which is So we always get two solutions effectively, but sometimes the solutions are the same, and we'll look at those cases. The methods we use assume that the right-hand side is 0 and the left-hand side has the form ax squared plus bx plus c. So ax squared plus bx plus c equals 0. So that's the sort of quadratic equation we're going to solve. So what's this saying? It's saying that we're going to look at 2 or 3 different ways of doing this thing, and they all rely on the fact, as we'll see, that the right-hand side is 0. The right-hand side is 0. So if it's not 0, we make it 0 by adding or subtracting whatever terms are on the right-hand side, so they go over the other side, to the left-hand side. So we make the right-hand side 0 if it isn't 0, because all these methods rely on that. And then the second thing is that the left-hand side has this sort of form, the sum term involving x squared. So a, the coefficient of x squared, is some number. It could be a fraction, it could be a negative number, it could be a positive number. So the sum term involving x squared, the sum term involving x possibly, and again b represents the number in front of it, the coefficient of x, and there's some sort of constant, some number as well on the left-hand side. So those are the 3 possibilities. There's some term involving x squared, there's some term involving x, and there's some constant. And then that the right-hand side equals 0. We're going to end up looking at a formula that allows us just to put in the numbers a, b and c, grind it out on a calculator, and out comes the answer. So you don't really need to think about it. So the formula method is what we're aiming for in the end. However, it's worth looking at 1 or 2 other methods, because in a couple of special cases, for example where b is 0, in other words there's no term involving x, or when c is 0, there's no constant, then there's a shortcut to the answer. So we're going to look at those 2 cases. If a is 0, then there's no term involving x squared, and that means you've not got a quadratic equation, so you just solve it as you would normally, a normal equation. So the 2 ones we're going to look at are if b is 0, in which case there's no bx, or c is 0. The first one, solving when b equals 0. In other words, it looks like that. Ax squared plus c equals 0. Okay, we solve this like a normal equation effectively. Let's get x on its own. What's the first thing to get rid of? No? Yeah, the c. X has been squared, then multiplied by a, and then c has been added. So the last thing was c was added, so get rid of that c term. Ax squared equals minus c. Subtract c from both sides. And then divide by a to get rid of the a. X squared equals minus c over a. Now how do I get rid of the squared? Square root it. And therefore x equals square root of minus c over a. Think about this for a minute. This square root, when I square root a number, or when I square root a number, I'm after a number that when I multiply that by itself, it gives me that value. So when I square this number, whatever it is, the square root of minus c over a, I'm going to end up with this value here. Whenever I square this answer, whatever it is, I'm going to end up with that. That has to be positive, because whenever I square a number, it's always going to be positive. So the first thing to recognize is that this must be positive. or the solution is not real. Not real, we say. We then have to think about introducing imaginary numbers and complex numbers, which we will be talking about. So that we've done some work. If you've done some maths with me before, we've done something on already. So we say, yes, there may be a result, a solution we can come up with, but it's a complex solution. It's not real. And so that's what we're going to focus on now, just real solutions. So that means this must be positive at the end of the day, or we stop and say it's no real solution. The next thing is, whenever I square a number, say I square -3, I get 9. -3 times -3 is 9. If I square 3, I get 9. So going back the other way, when I square root 9, I've no idea whether or not I've started off with +3 or -3. So when I square root, I always end up with plus or minus the answer. And that's the reason why there's two solutions. Because when you square root, there's always a possibility that it's positive or negative. So that's what gives you the two solutions when you solve a quadratic equation. I'll just pause. So first example, 3x squared plus 5 equals 0. Subtract 5, divide by 3, gives us a negative. And so there's no real solution. If I try and square root -5 over 3, get no answer. So looking at this, if this is positive, then when I subtract it from both sides, that's going to be minus over here. So I'm never going to be able to solve something that's like that. So if you learn to recognize it, you can say instantly, no solution. Or as soon as you bring this -5 over here, oops, I don't even need to divide by the 3 because that's negative, so it's not really doable. Okay. Another example. Give you one you can do this time. X squared, 3x squared minus 5 equals 0. Try that. I'll just pause. So x turns out to equal the square root of 5 over 3, which is 1.29 to 3 significant figures. But what have we got to put on that? Plus or minus, yes. Okay, two possibilities. Next one, solving when c equals 0. In other words, something like ax squared plus bx equals 0. There's no c. If it's not, this is when it starts to get really interesting, if it's not interesting enough for you already. And this is where we start to realize why it's important that the right-hand side is 0. If you look at the left-hand side, x appears in both terms. Because there's no c, we've got an x in both terms on the left-hand side, so we can factorize. We can take an x outside the bracket. So this implies that x into ax plus b equals 0. If I factorize it, I end up with that. To check it works, multiply back out again. X times ax is ax squared, and x times b gives xb or bx. So factorize, take an x, which is common to both of these terms, outside a bracket. Now, because the right-hand side is 0, that means the left-hand side must come to 0. And so, if x was 0, it wouldn't matter what the bracket was, the whole lot would be 0. So, if, in this case, one solution is x equals 0. And in the case where there's no constant, where there's no c, one solution is always 0. And in fact, the reason for that is because c turns out to be the intercept of that curve with the y-axis, the quadratic curve. So if c is 0, it cuts at the origin. In other words, x is 0 is one of the solutions. So if I type into an autograph, I'm looking for the situation where c is 0. So I type in a x squared plus bx equals, and I type in y. So I type in the function y equals ax squared plus bx, and then look for values where y equals 0. In other words, it's the x-axis. And by default, autograph sets any constant as 1. So I've actually plotted x squared plus x equals y. And you see the curve, here it is, and it always cuts at the origin because c is 0, it always cuts at the origin. So one of my solutions is always going to be that x equals 0. So it cuts when y equals 0 is along the x-axis. So one solution is x equals 0. What about the other solution? If we go back to here again, the other solution is, one solution is x equals 0, the other solution is the bracket is 0. In other words, ax plus b equals 0. So then I can solve that equation. To get x on its own, subtract b from both sides. So x equals minus b over a. So whatever a and b are, I could work out what x is. Example, 3x squared equals 4x. So to solve this, what's the first thing I do? Yeah, you'd think that, wouldn't you? But do you remember what we said right at the beginning? What must the right-hand side be? Yeah. Yes, I've got to make the right-hand side 0. For these methods to work, the right-hand side must be 0. There's no ifs or buts about it. So I must actually subtract the 4x from the right-hand side. So I get 3x squared minus 4x equals 0. Now factorise. Yeah, take the x outside the bracket, leaving 3x minus 4 inside the bracket. Now, x equals 0, or 3x minus 4 equals 0. So those are my two solutions. So solving this little equation, 3x equals 4, adding 4 to both sides, and x equals 4 over 3. So those are my two solutions, x equals 0 or x equals 4 over 3. Example 2, solve that for me. Find x. And hopefully you got this, x equals 0 or x equals 7.06. Note it's exactly 7.06, so they'll put 3 significant figures after it, so I've not rounded it. One more example of this, try this one, solve it for x. Hopefully you saw the shortcut with this example then. You can actually factorise more than just the x outside the bracket. If you can see a number that goes into both of these, and in this case I made it so that 260 goes into 520. If you see that, it makes life a lot easier for yourself, because x is still 0 for the first solution, and now we've got a much easier bracket to deal with to find the second solution. So if you can take something else, part of the number outside the bracket, that does work. So yes, that is a perfectly valid method. How would you check that this works, by the way, that if x is a half, that's a solution? It's always handy to be able to check it works, isn't it? Because if you're an engineer and you're out there on the field, you've not got someone there to check it for you. I need to know that that's the correct answer. So what would I do? Yeah, I'd put it into this one and check that 520 times a half squared minus 260 times a half is 0. Would you like to just do that? So look for these shortcuts when b is 0 or when a is 0, which is this one here. When b is 0 or when c is 0, rather, check, for those shortcuts, because it's much easier to solve if a or b is 0. Now, of course, we need to look at the example where we've got values for a, b, and c. So solving ax squared plus bx plus c equals 0. Again, we make sure the right-hand side is 0, so if any of the terms are over on the right-hand side, we get rid of them onto the left-hand side. And there are two methods that we employ. Two methods. One, factorize. And this only works sort of not general. So it works for some specific examples. But we need to look at it because it comes in to some integration methods that we'll be looking at later. So factorizing. 2, the perfect square method, which gives the quadratic formula. I'd like to spend some time looking at the perfect square method because it's a really nice way to solve a quadratic equation, but time means that I don't think I'm going to at this stage. I probably will do it next year maybe, but possibly not this year. We'll see how we go with time. In the textbook, the perfect square method is outlined, and it shows you in the textbook how the perfect square method leads to this quadratic formula. What I want to do at this point, though, is just give you the quadratic formula, which I'm hoping most of you are going to sort of half recognize anyway, which we use to solve simultaneous quadratic equations. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And you've been in the game as long as I have, you know that off by heart. Okay. If you don't expect to remember this formula, you will do over time. I guess somebody in this room will remember it, actually. Nobody? You recognise it? Well, that's halfway there. But some people have memorised this, but you will be given it in the exam. And, of course, in an engineering scenario, this is one of the classic formulas that are in any engineering text. Used to solve quadratic equations of the form that we've written down already, ax squared plus bx plus c equals 0. So it relies on the fact that you've made the right-hand side 0 and that a in this formula is the number in front of the x squared term, i.e. the coefficient of x squared. B is the number in front of the x term, i.e. the coefficient of x, and c is the constant. So that's what a, b, and c are in this formula. Assuming that you've made the right-hand side 0. So if you've not done that, it won't work. The beauty of this quadratic formula is if you get it in the form like this and you've made the right hand side 0, then all you've got to do is plug the numbers into the formula and type them into the calculator. Job done. Okay, so there's no thought involved, you've just got to put the numbers into the formula. Let's have a go at an example. 3x squared plus 4x minus 10 is 0. First thing you do is identify what A is, and what B is, and what C is. So A is 3, B is 4, and C is minus 10. This is just a case of banging the numbers into the formula now, but just one or two little things you've got to be aware of, and little pitfalls you could, or little mistakes you could make. And the main one is signs, because I've got a negative number in here, and the B might be negative as well. So you just got to be careful how you cope with the signs. So I would always recommend that you rewrite the formula, but with the values in it. So, and put those values in a bracket. So in other words, I'm going to write x equals minus b. And what's b? 4. So I'll put a 4 inside a bracket. Plus or minus, that's what gives us our two solutions. Plus or minus, because when I do the square root bit, remember, the answer could always be positive or negative. So plus or minus the square root of b squared. So what's b? 4. So put the 4 in a bracket. Minus 4 times a. What's a? 3. Put that in a bracket. Times c. Minus 10. Put that in a bracket. All over 2a, and a is 3. For this example, we've got nice whole numbers, and the more times you press keys in the calculator, the more likely you are to make mistakes. So you could just put this in as it stands, but I'd help the calculator out, and I'd do part of it myself. And I'd go, this equals minus 4. So looking at this a second, okay, when you put it into the calculator, don't bother with all these brackets. I've just put those brackets there, so I now know I've just substituted the values. And then look for the signs and work them out. Minus, this first bracket, minus 4, so that's just going to be minus 4, plus or minus the square root of 4 squared is 16. If that was a negative number in here, if this was minus 4, I wouldn't bother to do, like we were talking before, I wouldn't bother to put minus 4 squared in the calculator, because I might fall into that mistake of getting the negative like you found. So just put the 4 in. 4 squared gives me the 16. Now look at this. Minus, this is what I'm always looking for. I'm looking for the minus times the minus, because if this is negative as well, that makes it positive. So in my calculator, I've put plus 4 times 3 times 10. Well, in this case, you actually work it out. 4 3 to 12, 120. So I do that, okay? Have we got that right? Yeah. Over 2 3s are 6. Okay. Now this is what I put into the calculator. What do you do about the plus minus? What you do is you put the plus in or the minus in. So I put the plus in. So minus 4 plus the square root of 16 plus 120 over 6, or 136. And then leave the calculator. The calculator now will hold this little calculation, and you can scroll back and change the plus to a minus to get the other one. You don't have to put it all in again. So minus 4 plus or minus the square root of 136 over 6. Put plus in your calculator, and then when you've got that answer and made a note of it, go back, scroll back on the calculator and change the plus to a minus. X equals minus 2.61 or 1.27. Right, try this one. What's the first thing you got to do, Daniel, so you don't fall into a hole straight away? correct. The right-hand side must be 0. So the first step, subtract 100.2 from both sides, and then away. Put the values for A, B, and C in, see what you get. So if I were doing this, I'd note what A, B, and C were, noting that B and C were both negative. I'd put those values in. I wouldn't think about it. I'd just substitute these values in. Instead of B, I'd put minus 2.8. Instead of A, I'd put 13.6. Instead of C, I'd put minus 100.8. And then before I put it into the calculator, I'd sort the signs out. Minus times the minus gives us the plus 2.8. So that should be positive. Be careful of that one. That's often missed. Plus or minus the square root of. Forget the minus sign in there. Just put the 2.8 squared in the calculator. Note the minus times the minus again gives us the plus. So that would be plus 4 times that times 30.6 times all over 2 times 13.6. So that's what I type into the calculator here to get my two answers. Sorry, 100.2, right, yeah, 100.2 I missed, and that's another thing, yeah, I made a mistake there, and that is very easy to do, so watch for that as well. You know, it's easy to transpose figures incorrectly, so well spotted one. So those answers there, okay, to 3 significant figures, which is appropriate. We've got 2 here, so you can go to 1 more, to 3 maybe. Certainly not 4 significant figures. And how do we check? Put those values of x back in to the original function, original formula. And we should get round about 0. It won't be exactly because we've rounded, but it should be roughly 0. Yeah. What we're saying is both of those will give 0. There's 2 solutions. And if I plot an autograph, we can check that. Let me plot this original function on autograph. So if we go to autograph and type in, so let's close this one, start a new page. So y equals, what was the function? Original one, 13.6, if you, yeah, 13.6 x squared, 13.6 x squared minus 2.8x minus 100.2. And then, because we've typed y equals that, we're looking for where y equals 0, i.e. where it cuts the y-axis. So if we zoom out, we'll see the whole function. There it is. Zoom in on the x-axis to spread it out a bit, and we see our classic quadratic curve, and it cuts at roughly minus 2.7, which converge our answer, and plus 2.8 from the graph. So 2 solutions, 2 places where we get 0, so 2 solutions. In an engineering scenario, we're often really only interested in the positive solution yet, but there are 2 solutions. To finish this section then, now we've got the formula method to solve these quadratic equations. We've not looked at the factorising bit yet, we need to look at that, but we now have a method to solve the question we had at the start, which was this, solve by substitution, those 2. So we went through the method and we came up with a quadratic equation. Here it is. So let's use this quadratic formula that we've just arrived at to solve this equation. So here it is. What's the first job? Yeah, get rid of the 20 on the right hand side. Make the right hand side 0, so subtract 20 from both sides. It's minus 60 plus 32x equals 0. No, it doesn't know. Yeah, I mean, yeah. Yeah, I mean, that's always a good idea to write it like that so you don't make mistakes. Yeah. So this is A, this is B, and this is C. put the values in, not forgetting this is negative 60, and calculate them for me. So we've got these values for x. X equals 0.978 or minus 2.04. And if we go back to what we were looking at the beginning of today, this curve, where we had these two equations that we plotted them, we found that x was roughly 0.9. That was our guess. We now know it's 0.978 and minus 2.1. We've now got 2.04. So reasonable estimates from the graph. We could have zoomed in using also have got more accurate values. But now what I want you to do is to go back to these simultaneous equations. We've got values for x now. We know x, so we can use one of those equations to find y and confirm the values of y given here. And then once we've got our values for x and y, we can check in the other equation that we've not used to check it works. So would you like to just finish this off by doing that? And also, if you look in the textbook on page 84, there's a chapter solving quadratic equations. Let's just have a look for a second at this. So if you want to either open the book up or look at this, if we flip through the chapter, it starts off by talking about factorizing. That's something that we've not looked at yet. We'll look at that after half term. It's a particular method, but there's nothing to stop you looking at that in the meantime. If we flip through, it then talks about the perfect square method, completing the square. We're not worried about that at the moment, although if you want to have a look at it, please do. And then it arrives at the quadratic formula, as I said. So there's some there. And then it's section 11.4, page 88 is the one I want you to look at now. Solution using the formula method, which is what we've been doing. There are some worked examples there, but we've looked at some ourselves. So you could move on to exercise 44 and try some of those. Page 89. And even more interesting would be the next section, which is some practical problems involving quadratic equations, which will then lead us to exercise 45 on page 90. So if you'd like to have a look at those two exercises, exercises 44 and 45, between now and when I see you next time, which will be after half term, that would be good.